In fields glowing with clover and wildflowers, there exists a hidden city that never stops working. You can't hear its heartbeat, but it's there humming in the air, pulsing beneath the petals. This is the world of the honeybee. From a distance, a beehive looks simple, a wooden box, maybe with bees coming and going. But inside, it's a marvel of living design. Tens of thousands of individuals work in perfect coordination, building, cleaning, feeding, and defending their home. There's no visible ruler, no plan written on paper, yet the hive functions like a single living mind. Honeybees, scientifically known as Apis mellifera, have existed for millions of years. Long before humans built cities, they built theirs from wax, not stone, from teamwork, not technology. Their survival depends on cooperation. Each bee plays a small part in a much larger story, the story of one of Earth's most efficient societies. If we could shrink ourselves and walk through the entrance of the hive, we'd enter a world alive with sound and movement. Workers rush in from foraging trips, carrying nectar in their stomachs and pollen on their legs. Guards stand watch near the opening, sniffing every newcomer to make sure no stranger slips in. Deeper inside, nurse bees cradle tiny white larvae in wax cells, feeding them drop by drop with a mixture of honey, pollen, and enzymes. The temperature inside the hive is kept almost constant around 35 degrees Celsius. Even on cold nights or blazing summer days, the bees manage it with astonishing precision. When it's hot, workers line up and fan their wings to circulate cool air. When it's cold, they cluster tightly around the queen, vibrating their bodies to generate warmth. The hive behaves like one living body, each bee is single cell within it. Every sound, every movement has a purpose. The soft buzz of wings, the scent of wax, the vibration of comb, it's all communication. The hive is alive, and it's always listening. This is not chaos. It's order at its most beautiful. To understand how bees achieve all this, we have to look closer at the body of a single bee. A honeybee's body is divided into three parts: the head, thorax, and abdomen. The head is its control center, packed with sensory equipment. Two large compound eyes dominate its face, made up of thousands of tiny lenses that detect color, shape, and movement. Between them sit three smaller eyes, called ocelli, that sense light and help with navigation. Bees can see ultraviolet light, a spectrum invisible to humans. To them, many flowers have bright patterns we can't see, guiding them like runways toward the nectar. This is nature's invisible map, visible only to pollinators. From the head extends the proboscis, a long, straw-like tongue used for sipping nectar. It's flexible and precise, able to reach deep into flowers. When a bee drinks, the nectar goes into a special organ called the honey stomach. It's separate from the bee's real stomach, a portable storage tank designed just for nectar transport. The thorax is the powerhouse. It holds the muscles that drive the wings and legs. A honeybee's wings beat about 200 times per second, creating that familiar hum we associate with summer gardens. During flight, a system of hooks called hamuli links the front and back wings, turning two pairs into one large, efficient surface. This allows the bee to fly with remarkable control, forward, backward, and even hover. Then comes the abdomen, the bee's workshop. It contains the wax glands, venom sac, and digestive organs. The stinger at the tip is a modified ovipositor, a tool once meant for laying eggs, now used for defense. Worker bees, being sterile females, can sting to protect their colony, though they die afterward. For the bee, defense is always an act of sacrifice. Every part of the bee's body serves a purpose. The tiny hairs on its legs and body collect pollen. The antennae detect scents and vibrations. Even the color of its body, golden and black, helps it absorb warmth and warn predators. When you look at a honeybee up close, it's not just an insect. It's a perfect biological machine, designed by millions of years of evolution to sustain one of the most organized systems on Earth. Deep in the center of the hive, surrounded by warmth and darkness, lives one bee unlike any other, the queen. She is larger, longer, and moves with a calm, deliberate grace. Her role is singular, to ensure the survival of the colony through reproduction. But she doesn't command the hive like a monarch in a palace. Instead, she leads through chemistry, by releasing pheromones that influence the behavior of every bee around her. A queen begins life like any other bee, as an egg laid by another queen. But when the colony needs a new ruler, something extraordinary happens. The nurse bees select a few larvae and feed them a special substance called royal jelly. This creamy, nutrient-rich secretion triggers a complete transformation. The larvae fed on royal jelly grow larger and develop fully functional reproductive organs. Within days, one of them will become the next queen. When she finally emerges from her cell, the hive enters a tense moment. If other queens have also been raised, there will be no coexistence. Only one can survive. The newly emerged queen searches for her rivals and eliminates them, a brutal but necessary act to maintain order. Once she has secured her throne, the queen takes her nuptial flight. High in the open sky, she mates with a dozen or more drones from other colonies. Each drone that mates with her dies immediately afterward, leaving behind his genetic legacy. The queen returns to the hive, carrying millions of sperm cells stored in a special organ called the spermatheca. This single mating flight will supply her for years, sometimes for the rest of her life. Back inside the hive, she begins her true work. Moving methodically from cell to cell, she lays up to 2,000 eggs a day during peak season. She decides, in each moment, whether to fertilize an egg. Fertilized eggs become female workers. Unfertilized ones become male drones. The future of the hive lies in these tiny, white ovals she lays deep within the wax. The queen's pheromones do more than signal her presence. They unify the colony. They tell workers that the hive is healthy and guide them to care for the brood, collect nectar, and defend the entrance. When the queen grows old and her scent weakens, the bees sense it. They prepare a new queen, ensuring the cycle never breaks. Her reign may last for several years, but her purpose is eternal, the continuation of the colony. Without her, the hive loses direction. Without the hive, the queen is nothing. They exist only through each other, the many serving the one, and the one sustaining the many. In a world of honeybees, the workers are the true engine of civilization. Every bee you see on a flower, every bee that guards the hive, tends larvae, or produces wax, they are all female workers. They make up nearly the entire population of the colony. Without them, there is no hive, no honey, and no future. A worker bee's life is short but purposeful. During the busy months of spring and summer, she lives only about 6 weeks. Yet in that time, she performs a series of jobs that would take a human a lifetime to master. Her duties change with her age, guided by instinct and the needs of the colony. In her first days, after emerging from her wax cell, the young worker becomes a cleaner. Her first task is to clean the cell she hatched from, preparing it for the next egg. The hive must be spotless. Disease is the enemy of thousands living in close quarters. After cleaning, she becomes a nurse bee. She feeds the larvae a mixture of pollen, honey, and secretions from her glands. These young bees are the future workforce, and every mouthful she gives strengthens the colony. As she grows older, her glands develop further, and she begins producing wax. Small flakes form under her abdomen, which she kneads and molds into hexagonal cells, nature's most efficient shape. The wax comb becomes the hive's structure, nursery, pantry, and palace combined. After building, she might serve as a guard, standing watch near the hive entrance. Guard bees patrol constantly, recognizing fellow hive members by scent. Intruders, whether wasps, robber bees, or other threats, are stopped and attacked before they can enter. Finally, in the last stage of her life, the worker becomes a forger. She flies out into the world, visiting hundreds of flowers each day to collect nectar and pollen. This is dangerous work. Predators, weather, and exhaustion take their toll. Many never return, but those who do bring back the lifeblood of the hive. What makes this system remarkable is that no one assigns these roles. There's no leader shouting commands. The bees respond automatically to chemical signals, environmental changes, and the colony's internal needs. When more foragers are needed, some nurse bees will mature early and take flight. When more brood needs care, foragers may stay inside. It's a flexible, self-regulating society built entirely on communication and instinct. Each worker bee may be small, but together they form one of the most efficient and cooperative systems in nature, a living lesson in teamwork. Amidst the tireless female workers, there exists another class of bee, the drone. They're the males of the hive, and their lives follow a very different path. A drone's purpose is simple and singular: to mate with a virgin queen. Unlike workers, drones don't gather nectar or build comb. They have no stinger and perform no hive duties. Instead, they live leisurely within the hive, fed by their sisters, waiting for their one moment of destiny. Drones are larger and stouter than workers, with huge eyes that nearly meet on top of their heads. These eyes are designed for spotting queens in midair during the mating flight. Their flight muscles are powerful, enabling them to soar high into the sky where queens from other colonies pass. When a new queen takes her nuptial flight, drones from several hives gather in what's called a drone congregation area, an invisible aerial meeting place known only to bees. Dozens of drones chase the queen, competing for the chance to mate. Only the fastest and strongest succeed. The act is fatal for the drone. His abdomen ruptures in the process, and he falls to the ground. Yet, through that sacrifice, he ensures his genetic line lives on in future generations. Back at the hive, drones live comfortably through the warm months. But when the seasons shift and resources dwindle, their time ends. The workers, focused on survival, drive the drones out of the hive. It's called the drone eviction, a ruthless but necessary act. Drones cannot contribute to winter survival, so they are expelled, left to perish in the cold. This cycle may seem cruel, but it is part of the natural balance. Every drone exists for a single purpose: to pass on the colony's genes. Once that mission is fulfilled, nature moves forward without hesitation. In the honeybee world, every life, no matter how brief, has meaning. The workers build and sustain. The drones ensure the future. Together, they complete the circle of life within the hive. If you stand quietly near a beehive on a warm afternoon, you'll see bees flying in all directions. Some arrive loaded with pollen. Others rush out in search of nectar. To us, it seems chaotic, but within this motion lies one of the most fascinating communication systems in the animal kingdom: the waggle dance. The waggle dance is how forager bees tell their sisters where to find food. It was first decoded by the scientist Carl von Frisch in the 20th century, a discovery that earned him a Nobel Prize. Before this, no one imagined that insects could use a symbolic language to share information. Here's how it works. When a successful forager returns to the hive, she climbs onto the honeycomb and begins to dance. Her body moves in a figure-8 pattern, waggling her abdomen as she moves through the middle section. The direction of this waggle, relative to gravity, indicates the direction of the flowers in relation to the sun. The length of the waggle run tells the distance. A longer waggle means the source is farther away. Other bees crowd around her, touching her with their antennae to feel the vibrations and smell the floral scent she carries. Through this coded performance, the location of nectar fields miles away becomes known to the entire colony, all without a single word. But the waggle dance is only one form of communication. Bees also use pheromones, chemical signals that influence behavior. A queen's pheromones keep the colony calm and united. Alarm pheromones released by guards trigger defense behavior. Nasanov pheromones guide lost foragers back to the hive. Even the sound of buzzing can carry meaning. Bees fan their wings to signal cooling or vibrate their bodies to wake up workers and prepare for foraging. Communication in a hive is constant and complex, more like a living conversation than a simple instinct. What's truly remarkable is that this language is collective. No single bee controls the hive's actions. Decisions emerge from thousands of interactions. When the colony needs to find a new nesting site, scout bees perform dances for potential locations, and the hive collectively votes through repetition. It's a form of consensus-based decision-making, a natural democracy millions of years old. Through movement, scent, and vibration, bees have built a language that rivals any created by humans. It's a reminder that intelligence comes in many forms, and that cooperation, not conflict, can guide the most successful societies on Earth. Every civilization has its architecture, its blueprint for survival. For the honeybee, that blueprint is the comb, a network of perfect hexagons built entirely from wax. Inside a hive, the comb is everything. It's the nursery for the young, the pantry for the colony's food, and the queen's throne room all in one. Each cell has a precise purpose. Some hold developing larvae, others are filled with pollen or glistening honey. Yet every cell, no matter its use, follows the same mathematical design, the hexagon. Why hexagons? Because nature values efficiency. Circles leave gaps when packed together, squares waste material. But hexagons fit tightly, sharing walls, using the least wax for the greatest strength and storage. Scientists have proven that this pattern is the most efficient way to divide a surface, a truth bees discovered long before humans ever studied geometry. To build the comb, young worker bees cluster together and hang in chains, forming what beekeepers call a festoon. In the warmth of their collective bodies, small scales of wax begin to form under their abdomens. The bees chew these flakes, soften them, and mold them into walls and cells. Piece by piece, they construct the golden city within the hive. A single comb may weigh only a few hundred grams, but it can store several kilograms of honey. It's strong enough to hold the entire colony's resources, yet light enough to hang from a branch. It's architecture without architects, an instinctive miracle. The hive itself is organized with purpose. At the center lies the brood nest, where the queen lays her eggs and the young develop. Surrounding it are cells filled with pollen, the hive's protein supply, and farther out, the honey stores, sealed with wax caps like jars on a shelf. Near the entrance, guard bees patrol, while foragers come and go in endless motion. Every bee knows where she belongs. Every corridor serves a function. Together, they form one of the most advanced natural societies ever built, a city powered entirely by cooperation. Honey, that golden liquid that has fascinated humans for thousands of years, is more than food for bees. It's their lifeline, their energy source, their survival through the cold months when no flowers bloom. The process of making honey begins in the field. Forager bees fly from flower to flower, extending their proboscis to sip sweet nectar. Each drop is stored in the bee's honey stomach, separate from her digestive system. Inside, enzymes immediately begin breaking down complex sugars into simpler ones. When the forager returns to the hive, she doesn't simply dump the nectar. Instead, she passes it mouth to mouth to another worker in a process called trophallaxis. This exchange continues from bee to bee, reducing the water content little by little. The nectar thickens, transforming chemically as enzymes continue to act. Once it reaches the right consistency, the bees deposit the liquid into wax cells. Then comes the drying phase. Rows of workers fan their wings in unison, creating airflow through the hive. The gentle breeze evaporates moisture, leaving behind a dense, golden syrup, honey. When the moisture content drops to about 17%, the bees seal the cell with a thin layer of wax, preserving it indefinitely. Honey is remarkable for its longevity. Archaeologists have found pots of honey in ancient Egyptian tombs, still edible after more than 3,000 years. Its natural sugars, acidity, and low water content make it one of the few foods that never spoil. For bees, though, honey is not luxury. It's necessity. During winter, when flowers vanish and temperatures drop, the colony clusters together inside the hive. The bees vibrate their flight muscles to stay warm, consuming stored honey for energy. Without enough honey, the hive cannot survive the cold. Every drop of honey, therefore, represents thousands of flights, millions of wing beats, and countless blossoms visited. It's the product of pure effort and organization. Sunlight turned into sweetness through the labor of a living society. Inside the hive, life is a continuous cycle of birth, work, and death. Each bee lives for the colony, not for herself. Yet in that collective existence lies a kind of immortality. The hive endures even as individuals pass away. Worker bees born in spring may live only a few weeks. Those born in late autumn can live for several months, surviving the winter to raise the first brood of the next season. Their lifespan depends on the rhythm of nature itself. Death in the hive is not hidden. When a bee dies, workers carry her body out and drop it away from the entrance. Cleanliness is essential. Disease can spread quickly in such crowded quarters. In this way, the hive maintains health through constant renewal. When a colony grows too large, it may divide, a process called swarming. The old queen leaves with thousands of workers to start a new hive, while a young queen takes her place. The swarm gathers in a temporary cluster, often on a tree branch, while scouts search for a permanent home. Once a new site is chosen, the swarm moves as one, a living cloud of wings and sound. But the life of the colony is not without threats. Parasites like the varroa mite, diseases such as American foulbrood, and exposure to pesticides can devastate a hive. Climate change, habitat loss, and monoculture farming further endanger bees worldwide. Beekeepers and scientists now work hand in hand to protect these vital pollinators, developing treatments, breeding resistant bees, and restoring flower diversity. The strength of a bee colony lies not in any single member, but in unity. When one bee dies, another takes her place. When a hive falls, swarms elsewhere begin anew. It's a system built to endure, a testament to the resilience of nature. Human beings and honeybees have shared a partnership for thousands of years. From ancient cave paintings in Spain depicting honey hunters to modern beekeeping farms across the world, our relationship with bees is one of respect and dependency. Bees give us honey, beeswax, propolis, and royal jelly, but their greatest gift is pollination. Nearly 1/3 of the food we eat depends directly on pollinators. Apples, almonds, strawberries, cucumbers all rely on bees to transfer pollen and fertilize their blooms. Without bees, supermarket shelves would look very different. Early humans first gathered wild honey from hollow trees. Over time, they learned to keep bees in clay pots, woven baskets, and later wooden hives. Modern beekeeping, known as apiculture, developed in the 19th century with the invention of the movable frame hive by Lorenzo Langstroth. This allowed beekeepers to inspect colonies without destroying them. A revolution in bee management. Today, beekeeping ranges from small backyard setups to vast commercial operations with thousands of hives. Yet, despite human innovation, the essence remains unchanged, caring for a society that follows its own ancient laws. Beekeepers often describe the experience as humbling. Inside the hive, there's order without oversight, cooperation without command. Observing bees reminds us that balance and teamwork are possible even in the smallest corners of nature. But our bond with bees also comes with responsibility. Habitat destruction, pesticide use, and climate shifts threaten their existence. Protecting bees means protecting the ecosystems that sustain us all. Planting wildflowers, reducing chemicals, and supporting sustainable farming are small actions that make a big difference. Through bees, we glimpse a truth larger than ourselves, that every life, no matter how small, plays a role in the grand pattern of the planet. If there is wisdom to be found in nature, the honeybee embodies it. In their silent cities of wax, they show us that strength lies in unity, not in size. That progress comes from cooperation, not competition. That every action, no matter how small, can serve a greater good. A bee works her whole life for a community she'll never see completed. She gathers nectar she will never taste, builds cells she will never occupy, and defends a queen she will never replace. Yet through her work, the colony thrives. In a world often divided, the honeybee offers a quiet lesson. Harmony is not the absence of difference, but the successful balance of it. Each bee is unique, yet together they create a system that sustains life for themselves, for the flowers, and for us. Next time you hear that soft buzz in the air, pause for a moment. Somewhere nearby, a tiny builder carries the sunlight of a flower back to her hive. In that sound lives the heartbeat of the earth itself, steady, humble, and golden.